UV lasers are becoming increasingly popular due to their ability to engrave the widest range of materials compared to any other type of laser. With their ultraviolet 355 nanometer wavelength and photochemical ablation mechanism, UV lasers can process metals, plastics, ceramics, leather, glass, wood, and more with high precision and minimal heat-affected zones, offering broader material compatibility than any other laser class. Since publishing my reviews of the 5-watt and 10-watt ComMarker Omni, I've received many more questions about how these two models compare. In this video, I'll take a deeper look at their differences, focusing on more challenging materials, deep engravings, and cutting performance. I won't be testing easily engraved materials like most plastics, since both lasers handle those very well. If you're interested in that, check out my review of the 5-watt ComMarker Omni. For an overview of how UV lasers handle materials that are harder to engrave, watch my review of the 10-watt version. Wood is the material that has surprised me a lot when I tried to engrave and cut it with a UV laser. UV lasers produce little to no charring and can make incredibly deep and detailed engravings in wood. Let's start by comparing how both machines perform when engraving and cutting plywood using the same parameters. I tested engraving performance by engraving 2 high-speed crosshatch passes at varying frequencies. For cutting, I used 4mm thick poplar plywood at medium speed, changing the number of passes for each rectangle. Right away, it's clear that the 10-watt machine engraves significantly deeper and produces higher contrast. It also cuts the plywood much faster. I'm always impressed by how cleanly these machines can cut wood. While working with wood, I received many questions about how UV lasers handle deep 3D engravings. To test this, I created a quick design and ran 24 passes at high speed, adding a cleanup pass at a higher frequency every 4 passes to reduce charring. I first ran the test on the 5-watt model, followed by the 10-watt machine. It was satisfying to see the effect of the cleanup pass, especially for the final layer. The results revealed that the wood grain caused some variation in engraving depth, which could be improved with a more homogeneous wood type. But the performance difference between the two machines was striking. The 10-watt Omni achieved an impressive 5.5mm depth in just 24 passes, almost twice as deep as the 5-watt version. Next, I tested both machines on an aluminum plate. Aluminum is highly reflective, and it shows us that the more power you have, the better it will be engraved. Raw aluminum is either engraved or not, depending on the settings. There is very little in between. As expected, the 10-watt model performed significantly better, delivering stronger output across a wider frequency and Q-pulse range. The 10-watt machine also produced noticeably deeper engravings. As I demonstrated in my review of the 10-watt ComMarker Omni, with enough passes, a UV laser is capable of engraving very deeply into aluminum. I then engraved the same logo using the same parameters with the 5-watt ComMarker Omni. As expected, the engraving depth was noticeably shallower. However, when I halved the speed and doubled the number of passes, effectively taking 4 times as long, the result looked much more similar. This confirms that the 5-watt UV laser can also engrave deeply into aluminum. It just requires significantly more time to achieve comparable results. I also repeated the test I previously ran on stone with the 10-watt machine, engraving a logo at 500 millimeters per second with 15 passes. Interestingly, using the same settings, the 5-watt machine performed much more similarly to the 10-watt. This is likely because stone is far less reflective than aluminum. When I halved the speed and doubled the number of passes, the 5-watt Omni was able to engrave much deeper. Both lasers can perform very differently on some materials. If you watched my comparison video between UV and fiber lasers, You may remember I mentioned that UV lasers couldn't engrave certain types of stone. Specifically, I showed that they couldn't engrave this river stone. I need to correct that. I later discovered my parameters were set incorrectly during that test. After adjusting them, I was able to engrave this natural stone without any issues using both UV lasers. It just takes more passes than with a fiber laser. Since I previously showed how I engraved a PCB with the 10W ComMarker Omni, many of you asked whether the 5W version could do the same. I ran a quick test to compare how both machines remove the copper layer from an FR4 board. While both were able to remove copper, the 10W laser did it much faster and also engraved deeper into the base material. This suggests it could potentially be used for drilling holes and cutting traces as well. Now for perhaps the most important material, glass. I started by testing how fast each machine could engrave tempered glass. I used a pattern that varied speed and frequency settings. The results show that the 10W Omni can engrave glass more than twice as fast as the 5W version and produces much deeper marks. When I demonstrated how I engraved in the middle of the glass using a 70mm lens with the 10W model, many of you asked if the 5W model could do the same. So I installed the 70mm lens on the 5W Omni, focused it in the middle of a thick glass medallion, and engraved text at slow speed with multiple passes. I placed a stone beneath the medallion to avoid staining from laser reflections. The result was a clean, embedded engraving, very similar to what the 10W Omni produced. The only drawback is that the 5W laser takes twice as long, and the process is already time-consuming. Next, I wanted to test the usable engraving depth on a curved wine glass. I focused both lasers on the very top of the glass surface for consistency, even though it's not the ideal focus point for this case. Ideally, you would focus the machine a bit lower. Using a low speed of 150mm per second and a coarse crosshatch fill, I engraved a square with both machines to test the maximum engraving range. Surprisingly, the 10W ComMarker Omni engraved a pattern that was only slightly larger than the one made with the 5W one, which didn't make sense to me. To investigate, I ran another test on an angled piece of glass. I focused both lasers at the top of the two blocks, placing the ideal focal point around the middle of the engraving surface. I then engraved a narrow rectangle using a crosshatch fill, first with the 10W machine and then with the 5W. The results clarified everything. The focusing stick I used for the 5W model was about 1mm too long, which shifted the focus lower in the engraving range. In contrast, the 10W model was perfectly focused right at the level of the two blocks as the pattern is symmetrical above and below this line. This explained why both machines performed similarly on the wine glass despite their power difference. It was because the 5W Omni was focused lower, and this has caused it to have an advantage in this case. A wider focus range allows you to engrave larger designs on curved surfaces. This is especially applicable to glass, because when a UV laser goes out of focus in glass, the beam can refract inside the material and end up engraving the inner surface of the glass instead. Still, one of the coolest things you can do with a UV laser is to cut through the glass itself. By letting the engraving process run for longer, these machines can easily chew through the glass, opening cool new ways of customization. Of course, the 10W machine can do this faster than the 5W. I also wanted to test whether it's possible to anneal stainless steel using a UV laser. I started by engraving several test patterns while keeping the machines in focus. Interestingly, the 5W Omni actually performed better in this case, as I couldn't reduce the engraving power on the 10W model enough for such tightly spaced lines. Because of that, the majority of test patterns resulted in rough brown colors instead of a smooth black surface. The 5W ComMarker Omni was even able to produce a few colors, which is a result of a true annealing process. However, when I defocused the 10-watt machine by 10 millimeters and ran the test again, the results improved significantly. With a bit more fine-tuning, I'm confident I could achieve even better outcomes. So yes, annealing stainless steel with a UV laser is definitely possible, but fiber lasers still have an advantage in this area. Both the 5-watt and 10-watt UV lasers deliver impressive performance across a wide range of materials, from wood and glass to metals and stone. While the 10-watt model offers faster, deeper, and more efficient engraving, especially on tough or reflective surfaces, the 5-watt version can achieve similar results with more time and passes. If you need higher speed and throughput, the 10-watt is clearly the better choice, but the 5-watt remains a capable and versatile option for less demanding workloads. Thanks for watching. Don't forget to like, subscribe, and drop your questions in the comments.